Okay, everybody. So welcome. So now we are moving out of the finance stuff and we are moving into unit three, which is set theory and logic. Now, there's going to be a lot of definitions to front load this. We are going to make you a cheat sheet that you're going to need for this. But before I kind of go into this, like what is set theory? What is logic around this? I want you to think about this example here. And you don't have to write this down. In fact, I wouldn't, or use a scrap piece of paper just so stuff is kind of split up here. But I want you to think about um, how, again, you don't have to write this down. How do you organize your kitchen? Really pause and think about that. How do you do it? I can tell you how I organize my kitchen. For example, where have I put the plates and the bowls and the cups, the pots, the pans, the lids, the cutlery, and so on and so forth, right? So, how do you organize those things? You probably have a cabinet for each of these, right? Or maybe you pair, oh, I put the plates beside the bowls and I put the cups in one thing. And the pots, I put the pots in one cupboard and pans in the other one, and the lids go with them. And then, the cutlery goes in a drawer. So maybe you organize something like that. So these here are an example of what we might refer to like something like sets. Again, I'm going to refer to this kitchen stuff again. You don't have to write this down. But I can take these things, for example, I'll tell you what I do. First off, my plates, I have the big plates. Sorry, I have small plates, small circle plates. I have big circle plates, and I have big square plates. You know what I do? I stack the big circle plates on top of the square plates, but I take these little guys and I put them somewhere else. So I organize my plates in the same drawer, but I further organize my plates by themselves. So I can keep organizing these things more and more. For example, maybe with my cups, well, maybe I put the glass cups on the bottom, but the hot cups on the top, or maybe one's left, one's right. So you might have certain ways to do that. Maybe I do tall and short cups a certain way. If you look at cutlery, for example, well, you put it all into a drawer, right? But you probably put the forks in their own little compartments, the spoons in their own compartment, the knives. What if it's sharp? What if it's a butter knife? What if it's kids' utensils? What do you do with those? So there's further and further set theory and logic here with how you do this. Is there anything else in your life that you organize? You have a certain way of doing that would fall into this? How do you put clothes away? What goes in a closet? What goes in a drawer? Is one an underwear drawer? Is one a sock drawer? Maybe the left side of the drawer is underwear and the right side of the drawer is socks. Maybe you just have so many of their own separate thing. Everyone has their own way of organizing things. There's a logic to it, and there's a way to break it down further and further and further. For example, if I'm looking at underwear, maybe my fancy sports ones that I want to wear on a hot day or when I'm working out, those go somewhere else, opposed to my regular underwear, maybe opposed to the ones that I need to throw out. Maybe they all go in their own separate place, all in the same cupboard. They're all underwear, but they all go somewhere different. So everyone has their own way of operating like that. So that's what this unit here is kind of about. It's about figuring out the math behind that. So we're going to make ourselves a cheat sheet here. So we're going to start off here with unit 3.1, types of sets and set notation. Now, there's going to be a lot of definitions here to start out with. The first thing I want to talk about here is a set. So a set is a collection of distinguishable items. So a set of distinguishable items. If we're using numbers, for example, it might be 0, 1, 2, 3. But I want you to really pay note to the letters that we're going to use here. It's a W. These are whole numbers, for example. Um, we're also going to have elements. Come on. Which is an object of a set. For example, 3 is an element of D. We're going to talk about this. We're going to talk about this. Where am I getting D from? What's going on? This is where I want to introduce you to a universal set. Okay? So a universal set is a set under all the elements under consideration for a particular context or like a sample space. So for example, we're saying that, hey, here's my D. My D contains all these numbers here. Maybe I'm referring back to my underwear or my plates or my different types of cups or my cutlery. These are all cutlery, but they're all their own unique thing, for example. Okay. So a universal set here would be a set under all of the elements for consideration. For example, cutlery might be a universal set. Just a set in general might be my kitchen items. But an element might be my cutlery. I have my knives, I have my forks, I have my spoons. So these are all some examples. Now we've talked about, though, I can have subsets. I can have subsets. For example, well, what's a subset? Maybe a subset here is my my sharp knives versus my butter knives versus my children's plastic knives. Maybe it's my dull knives versus my sharp knives, whatever it is, right? So, and sorry, I should have clarified. It's okay to pause this later to write it down. I want you to understand it first. Really important we understand what the heck's going on. There's a lot of definitions here. And then we have a complement, and I think that's our last. Oh no, there's more. Like I said, cheat sheet. This is your cheat sheet, and trust me, I'll give you some visual stuff for this as well. Then we have a complement. This is all the elements of a universal set that do not belong to a subset of it. They do not belong to a subset of it. And we use this little thing here. You see that little dash at the end? That little dash means that this doesn't belong. Okay? So for example here, if I have my plates, so let's say my set is my kitchen item. Kitchen items, right? Maybe I have a can of beans in there. That would not belong to my kitchen items that I'm referring to them, right? I'm talking about my cups and plates and cutlery and stuff like that, pots and pans. The fact that I have a can of bean there is irrelevant in this case. So I hope that makes some sense here. Now, there's a couple more definitions, but I want to now go over the notation. So if you're looking here, this W, whole set. This D is the universal set here. These are just some examples here that they're given. A subset here, they might use an O. Now, they have this little, we call this a prime. In fact, I'm going to write that down. This is O prime. Right? Does not belong. It's a complement. Subset here, there's some notation. We'll talk about what this C means in a second here. Like, what the heck is that thing? But there's that involved there. And then I think we just got two more. I think we have an empty set, which is a set of no elements. So a set of no elements here. And we use these little squiggly brackets here, right? We use, oh, come on. These bad boys. Let me make those bigger for y'all. Oh, I froze it. Oh. All right. Right, this stuff here. Or we use this thing here. Little O with a line through it. And then finally, we have a disjoint. And again, if you're confused right now, that's fine. I'm blasting through this. So this is two or more sets having no elements in common. So no elements in common. For example, a set of even numbers and a set of odd numbers have nothing in common. Set with no elements, a set whose elements all belong to another set, an object in a set of all items on consideration. Okay, and then a collection of distinguishable objects. Okay, so at this point, I'm going to zoom out here. Write down your cheat sheet. There's going to be more of this cheat sheet in a bit. So if you can, condense it a little bit further. If not, you're just going to have a 2-page cheat sheet, and that's fine, okay? Do what works for you. You're going to be drawing some stuff after the fact here. So pause the video. 3, 2, 1. Cool. Okay. More for your cheat sheet here. Remember this little C thing here? What does that mean? We're gonna learn more about this in a bit. For now, I just want us to get it down, right? We want to keep the cheat sheet in a nice, easy to understand place. We have set operations. There's some lovely diagrams here to kind of help you out. And then there's also, give me 1 second. Okay, so before you panic about what you're about to see and what you're gonna have to write down, I want to be really clear. Everything you're about to write down is for the entire unit. We're going to break it apart piece by piece by piece. Okay? So don't panic. Don't freak out. But this is everything we're going to learn in this unit. This is your cheat sheet. This is not everything we're going to learn in this section. We are going to introduce the topic in this section. Okay? We'll break it apart piece by piece by piece by piece. But we have basic set definitions. Oh, I need to actually write this stuff down, I guess. That'll probably be pretty helpful. So we use those squiggly lines here for what a set definition is, right? Remember these bad boys? Those things. Now, if something's a member of, it's kind of like this weird little E. This weird E. This means that an element belongs to a set. A knife, a fork, belongs to cutlery. So fork belongs to cutlery, for example, there. If something's not a member, it's the same signal. It's the same weird E. We put a line in it. For example, a bowl does not belong to cutlery. If something's an empty set, remember this thing? This is just the stuff from up above, right? This little O with a dash through it. Or you just have an empty set. That's a set with no elements. A universal set is, we kind of just put this weird little U here, fancy schmancy U, handwriting U, for it. Right? I think that's all pretty sure. I want to keep it consistent with the book. There's some people teach these different ways. I want to keep it consistent. I think we're good. Yeah. All right, just double checking. Oh, yeah, okay, we're good there. So next we have a subset. And again, you don't need to understand this right now. That's fine. We're going to be doing this through the next couple weeks here. So a subset it's a C with an underline. So A subset B means every element in A is also in B. A proper subset is just that big old C by itself. So A subset B means A is a subset of B, but also A equals B. Again, we'll talk about it. A superset is just this backwards C with an underline through it. So A superset B means all elements of B are in A. So it can go both ways. Think if you remember the alligator, like which way is the alligator going for? It's kind of the same thing. You can draw little teeth in there if you want. And then equality is just an equal signs, right? Next we have union. This is just a big old U. So A union B means if something's something in A or B or both. Intersection means only stuff that is in between. So there's a U for union and an N for, actually no, technically not an N. Technically, it's an upside down U, but you can pretend it's an N for intersection. Complement, remember it's that little prime symbol there, and then difference is just a little minus sign, here. And then here's just some examples. Okay, so get that all down. Get that all down. Pause the video, come back to it, and then we'll actually learn this stuff. Okay, so 3, 2, 1. Okay, so first thing here, I want to talk about is this. Let's bring the math back into it here. We've talked a lot about like kitchen stuff, for example. So we have some notation here. So a couple things to note. So the following is a summary of notation. So this is all we need so far for it. Okay, we don't need all this stuff yet. We're just going to start out with really simple. First off, we're going to have a set. So we're going to give you the set of the numbers 1, 2, and 3, right? So here's a universal set. Here's your squiggly lines, and here's all of it listed in there. If I were to give you a set, for example, of a roll of a dice, well, that would be 1, 2, 3, 4, 5, and 6. If I were to give you the one of a deck of cards, that would be the ace of hearts, the 2 of hearts, and so on and so forth, right? So those are universal sets. It's everything that's in that set. Now we're going to say that set A is just numbers 1 and 2, right? So set A is 1 and 2. So all elements of A, right? Everything in A, which is 1 and 2, is also in U. So this is a subset of U. So I hope that makes some sense there, right? 1 and 2, which is set A, is also a subset of our total data, our total universal set. So A is a subset of U. That's how you read this. A is a subset of U. That said, A prime, what's prime again? What's prime again? What's prime again? It's a complement. That means it doesn't belong. So A prime means does not belong in A, right? Well, of all these numbers here, which one doesn't belong in A? It's 3. So A prime, right? Pay attention to that little thing there, is 3. So what if I ask you, what about the number 4 or any number that contains the number 4? Which is that a part of A? Is that a part of U? No, that is not a part of that. So we would say it's an empty set, right? There's nothing in there. Or B is equal to, again, no set. So B is a subset of U. No, not really. I don't know why they put that there. Get rid of that. All right, so to get that down, and then we're going to run into this here. Okay, so let's start out with this. So we're going to do example 1 here. All right, so we're going to do example 1. This is where your cheat sheet's going to come in handy because you're going to have to refer to it back and forth. You're going to have to flip back and forth until you get it, okay? You might want to even take a picture of your cheat sheet. That way you don't have to actually flip back and forth. Anyways, so question A here, indicate the multiples of 5 and 10 from numbers 1 to 150 using set notation, and then list any subsets. So first off, let's define the universal set, right? Remember, universal set. I'm not going to italicize it just because, I don't want to, but like ideally it'd look kind of like that, right? Yeah. I use U. I'm writing U. All right. So next, use my squiggly lines. So it's 1, it's 2, it's 3, it's 4. I'm not going to list all 500 numbers, right? Instead, ... 498, 499, 500. There it is. There's my entire universal set. Every number that I'm referring to is going to be within this. Okay? Now that said, I want to indicate these multiples of 5 to 100. So first off, let's put this into a set notation here, right? So this universal set here is equal to any digit. I'm going to use X here to represent that. Any digit. Solid line. That's equal or greater than 1. That's less than, that's larger than or equal to 1, but smaller than or equal to 500. Again, think about the alligator stuff, but I'm putting this little thing, all right? This means equal. If at this point you're confused, you're going to have to do some quick research, so quick Googling into equal or less than and equal or greater than. So pause this video here and do that if you don't know what those look like there. So first off, I'm saying X. X is going to be this any number I want. I could put P there. I could put X. I could put Y there. I could put a question mark there. But generally in math, we use X, right? So this is saying that, hey, any number, but that is large, that is bigger or equal to 1 or smaller than equal to 500. All right. So comma, AKA what this is saying that X is a part of natural numbers. We use a little E there. So X is a member of N. Oh, sorry, I got to close my set too. Okay, so this is set notation here. So you have to be able to read this. This is telling a story, right? Again, X can be any number. X can be any number, but it has to be between 1 and 500. Equal or between 1 and 500. That's what this is saying here, right? So I've done that as set notation. Now I need to do my subsets. What are my subsets? Multiples of 5, multiples of 10, right? So let's do that. I'm going to say A. I'm going to say A. So A is going to be our multiples of 5, right? Just for context. So A is equal to set, right? It's 5, it's 10, it's 15, so on and so forth until you get to 490, 495, 500, okay? So A equals, again, let's put, what number do I want to put here? I'm going to say, I don't know, fives, F, 5. 5 is F. That's why I'm putting F. I could put whatever I want. I could put T. I could put H. I could put K. Whatever it is. I'm putting F because I'm talking about fives, right? So just like before, right? So we're saying, hey, given the algebra term F is equal to 5x, right? What's x? Well, any of these numbers times 5, right? But again, x can only be 1 to 100, right? I can't put 500 in there. So any number between 1 and 100, all I got to do is times it by 5, and I get a multiple of 5, right? As long as x is a member of a natural number. The natural number. If you're like, where'd you get those natural numbers from? Do they even talk about it? Oh, they don't even talk about it. All right, well. Okay, so again, how do you read this? To find F, to find a multiple of 5, right? Because that's why I put F there. To find a multiple of 5, I take any number between 1 and 100 and I times it by 5, as long as that number is a member of a regular natural number. Okay? So, which means F is a subset of S. So F is a subset of S. Check. That's one subset. What's my other subset? A multiple of 10. So I'm going to call that subset B. And then I'm going to say, this is multiples of 10s. So I'm going to say that B that's 10, that's 20, that's 30, so on and so forth. That's 480, that's 490, that's 500, right? That's them all listed out. So B is going to be equal to, I'm going to use T, right? T for tens. So I'm saying that, hey, T is a multiple of 10. What is T? Well, to find T, I take any number, which is X, and I times that by 10. It's 10X, right? Which means, well, if the set's 500, what times 10 gives me 500? 50, right? If this is, so this is the smallest one, so 10 is the smallest one. Well, 1 times 10 gives me 10. 50 times 500 gives me, sorry, 50 times 10 gives me 500, right? So as long as X is between or equal to 1 and 50, this works out, right? As long as X is part of a natural number. So I hope this is starting to make sense. Again, it's okay if you're a little confused still. This is going to take time. You are effectively learning another language. So if you're like, I think I get it, but like I don't, that's fine. Yeah, that's normal. If I were to giving you a lecture in another language, you'd have no freaking idea what I'm saying, right? It's going to take you time. You're going to struggle. You're going to refer back to it. This is why I said that this picks up at this point. You need to put more effort in because it's stuff just takes, it's a little bit harder to learn because we're speaking in different languages. So B is a subset of, sorry, I don't know why I put S here, of U. My bad, my bad, my bad. I don't know why I put S there. So B is a subset of U, right? Now that said, gotta remember 10, 490, 500. Oh, everything in A is also in B, but not everything in B is also in A. Oh, so actually, all of our all of our tens is a subset of all of our fives. Sorry, all of our subset. So B, right, is a subset of A, which is our five. So our tens are subsets of fives, right? But A is a subset of all of our numbers. So I got to write both of these. And then finally, um, we would say that A prime, A prime is equal to the non-multiples of 5 from 1 to 500. That's another thing we could do there. So these are all examples here of answering this question, right? So here's all of our subsets. So here's our multiples of fives. Here's our tens. We're showing how these are related here to our universal data set. And then we're showing the outliers, the things that don't exist. Yeah, that looks like yeah, okay. So next thing we want to do is we want to represent, so question B, represent the sets and subset in a Venn diagram. Venn diagram. Now, what's a Venn diagram? That is this stuff up here, right? So for example, if we're using these fives, tens, and 100s here, if I'm using this stuff up here, set A might be our fives. These might be our tens. So for example, if I give you the number 20, it works out for this first example here, right? Because it is both a member of 5 and it's a member of, well, actually, no, I'm not going to go there. We're not going to go there yet. So we want to represent the stuff here into a Venn diagram, right? So those circles. So first off, let's draw ourselves a little square here. No, not that. No. Here we go. Draw ourselves a rectangle. Oh, no, 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 no. Here we go. So this is going to be our this is our set. These are the numbers 1 to 5, 1 to 500 in there, okay? So first off, we're going to draw a little circle here of our we're going to say these are our tens here. These are our tens, right? Or this is subset B, right? This, sure. But also, I need a better mouse. We have our subset of our fives, right? Which we say is F. All of the tens are a part of five. All of the tens are a part of the fives, but not all the fives are the part of the tens. So anything that isn't a five, right? A prime isn't a five, is outside of this, right? So the number two is out here. The number three is out here. The number four is out here. Where's the number five? Five's in here. The number six is out here. The number seven's out here. The number eight's out here. The number nine's out here. Where's 10? 10 is both a member of five, but it's also a member of the tens, which is why it's here. And I would do that so on and so forth for all the numbers. Now, you don't actually have to write these numbers in. You don't actually have to do that. I'm trying to cross it out here. Actually, yeah, let me do this. Right? So I don't actually have to write these numbers because they're covered by this. Okay? And then finally, everything else, right? So we would say that, oh, the entire data set is out here. The rest of the data set's out here, the union. Um, yeah. Okay. Wanna. And so again, why this works here, why we did this Venn diagram, remember the tens are a subset of the fives, right? So that's this one here. All right. I think I'm going to skip example two here. I don't think it's that relevant. It's just a lot of busy work in this case. All you're doing is you're adding up. So for example, this is, this is one. This one here is when you have, how they do it. They did 2 rows, 3 rows, 4 rows. A fifth row would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And you just keep doing that until you get up to 100, basically. Just a lot of busy work. They did a chart here. I encourage you to actually look at this example if you guys run into any questions like this. But I trust you'll be able to handle it. So let's go to, here we go. Example 3. I want to do this one here. So I'm going to give myself the cheat code. You guys got to write it down. So write this down and then we'll start running into this here. All right. So Annie and Connie rescue homeless animals and they advertise in the local newspaper to find homes for the animals. They're setting up a web page to help them advertise the animals that are available. They currently have dogs, cats, rabbits, ferrets, parrots, lovebirds, macaws, iguanas, and snakes. Draw a Venn diagram to organize the animals on, a way to organize the animals on a web page, and then organize it using a Venn diagram. For example, do we want to go with number of legs? Do we want to go with whether they have fur or feathers or scales? Do we want to go with warm-blooded and cold-blooded? And so there's 1,000 different variations of this. How did these guys do it? They did. Oh. Okay, they did cold-blooded versus warm-blooded, which I guess I probably would have done it like I probably would have done like something like traditional pets. Sorry, I personally would have done feathers, furs, and scales, but um, wow, I don't like how they did this. You know what? No, we're doing it our way. That way you guys can see it twice. All right, our way. We're doing it my way. Um, so for question A, we're gonna do it with fur. We're gonna do it with feathers, and we're gonna do it with scales, right? So, for example, for our fur, we're writing this out in plain English right now. Once this makes sense to you, you don't have to, but it's a good way to organize it. So, for fur, what do we have? We have dogs, we have cats, we have rabbits, and we have ferrets. For feathers, we have parrots. I assume lovebirds and macaws. Macaw's a bird, right? But macaw. I'm Googling it actually because I don't actually know what a macaw is. Um, macaw. Yes. Okay. So we have macaws, which is a bird, and then we have scales, which is going to be iguanas and snakes. All right. So let's organize this here. So we're going to go first off, the universal set U is going to be all the animals, right? Sorry, all the animals. We have to use proper notation here. We're going to say F is going to be the furry animals. We're going to say, oh crap. You know what? We're going to say FU is all furry animals. You know what? No, we can't. We have to stick with one letter. Let's keep it simple. Feathers, instead of feathers, it's birds. Birds now. B is going to be all all the birds. And then S is going to be the scaled animals. So this would be turning this into a set here, right? Kind of. Your F in this case, you have to actually list them, right? You have to actually list them. It's your dogs, it's your cats, it's your rabbits, it's your ferrets. We're taking that list from up above and we're putting it into proper notation. Your B in this case is your birds, right? So doing this properly, it'd be birds, lovebirds, and macaws. And then scales properly would be iguanas and snakes. So technically, the stuff on the right is the correct way to do it, the proper math notation here, right? So now we have a universal set. Here's our universal. And then we have our subsets, right? Okay. Again, I'm just doing this to help further explain it. You can just go straight into, you could go straight into this. If you really wanted, that's fine. If you know what you're doing, awesome. All right. So design a way to organize the animals on the website. Check. Represent your organization into a Venn diagram. Okay. So into a Venn diagram. Now, how they did it was they did warm-blooded and cold-blooded, right? Warm-blooded, big set of warm-blooded, and then they had subsets. For us, that's a little bit different. Now, for us, right, big old rectangle, do your circles. For us, there's no overlap whatsoever between these three. Nothing here has scales and feathers and fur or whatever. So for us, they're all three are separated, right? We have our fur, we have our birds, we have our scales. Boom, boom, boom. Is there any animals we're missing? No, there is not. We are good to go. But remember, this entire thing encompasses The universal sets. I got to put that in there. I got to put that U in there. Okay. So check. I've done that. Name any disjoint. Any disjoint sets. I want you to think about that. What is a disjoint set? Would there even be one here? So a disjoint set in this case, if you had to Google it, you would see that it would be how do I explain it? Like the nothing in common. It'd be two sets that don't have anything in common. Okay. And in this case, the question B, which are disjoint sets. So remember, a disjoint set is two or more sets that have nothing in common. For this one here, the warm-blooded and the cold-blooded, they can see that the disjoint sets are the warm and the cold. For us, the disjoint sets are the birds, the feathers, sorry, the furs, and the scales. Right? So it would be B and F, B and S. Yeah, just like that. That's fine. Now, question C here asks us, show which sets are subsets of another using that doesn't work with our example. They did not do. Did they just? This is a terrible question. We've done that. None of them are subsets of each other. Alden said that the set of fur-bearing animals could form one subset. Name another set of animals that is equal to this equation. You can put non-furred in that case. So okay, so we're kind of done with this one actually. So easy enough. Example 4. I don't think we need that one. Okay. Awesome. So we'll put our key ideas here. I know this was a lot, okay? Again, you just started learning a fresh out of language. This is probably going to be the assignment you're going to struggle with the most just because you're still learning the language. Once you get the language, the rest of this chapter of all of, so 3.1, 2, 3, and 4 will be easier. Sorry, 3.1 to 3.6. So you have to understand this language, which means this type of stuff up here has to start making sense. The stuff from example 1 specifically, that's got to become a little bit more fluent with you. And that's going to take time. So if you're the student who's like, oh, I don't do all my practice questions, do all your practice questions, especially for this. You need to. It needs to become intuitive for you. All right. So in terms of the questions to do for your textbook, so 3.1 textbook, you know what? Do them all if you can. Refer to the examples above, right? Like above here, there's there's example 2 and example 4 we didn't actually go through. So do all of them. Do all of them in your workbook. Then do the assignment. Now for this assignment, refer to the details that are going to be below on here. But it's probably going to be a combination of workbook, textbook, plus an additional thing. I'm pretty sure that's what I want to do with that. So I'll let you guys get into that though. Awesome.